So we're going to look now at another really big C grade topic, and it is this. Use Pythagoras to calculate missing lengths in right angled triangles. And you're going to find this most commonly on a foundation paper, calculator paper, getting towards the end of the paper because it's C grade. So we've got this right angled triangle. This only works with right angled triangles. So if you've got one of those, right angled triangle, and you've got a length missing, you've got to find it out in some stage in your problem, then you've got to be using Pythagoras. So our question here says, calculate length AC, leaving your answer correct to 2 decimal places. So there we go. Now, Pythagoras was a mathematician, a Greek mathematician, lived about 600 years BC, and he discovered this, that if we find if we take this square here, or we draw a square there, and we draw a square there, if we were to find the area of those 2 squares, add them together, it will actually make the area of that square there. So let's just have a look at that. Now, the area of that square there, how are we going to work that out? Well, if that's 7, that's 7. So it's going to be 7 times 7, which is 49. And over here, the area of this square is 5 times 5, which is 25. So Pythagoras realised that if I add those 2 together, then that will make the area of that square. So that is 25 plus 49, that is 74. So now, that square, that 5 squared, gave us the area of that square. That 7 squared gave us the area of that square. Putting the 2 together gives us 74. So we're now looking for this length, that when we square it, we get 74. So how will we work out what that length is? Well, what we've got to do is we've got to find the square root of 74. Now this is where it comes to knowing your calculator really, really well. Up at the top half of it, you should have your square root sign somewhere. If you can't find it easily, it may be above the x squared button, in which case you might have to press the second function first in order to get it. Now on my calculator, I'm going to press in the square root sign, then 74. But on some calculators, you might have to press in 74 first, then the square root button. But you're going to need to practice that to see what works on your calculator. The answer I get, and I need it correct to 2 decimal places, on the calculator it says 8.602325 and so on. If I round that to 2 decimal places, that's 8.60 centimetres. So that's my answer there, 8.60 centimetres. So that's the answer. But I can do that in a shorter way without having to draw the square. So we'll just run through that. Some people find drawing the squares is really helpful, so do that if you need to. But anyway, this is what we're going to do. First job, if you remember, when I had this square, I found out the area of it. And I did that by doing 5 squared. Then I found out the area of this square, and I did that by doing 7 squared. Then I added them together, so I'm going to add those together. And they will make this square. So if you like, I'm just going to call that x at the minute. They're going to make x squared when I add them together. And so Pythagoras sort of shortens it to this. He says that a squared plus b squared equals c squared. That's often what you'll see as Pythagoras' theorem. That's not the same as these letters here. So all that represents is A is one of the small sides, B is the other small side, and C will be the longest side, which is opposite the right angle. So A small side, B small side, C the longest side. So 5 squared is 25, 7 squared is 49, and obviously I still don't know what x squared is, but what I'm doing each time is a new line. So 25 plus 49, well that's 74, and that equals x squared. Then I needed to move the square root sign over. Now I'm square rooting 74, and that's x. So again, I find on my calculator here that square root of 74, square root of 74 is 8.60 centimetres. Okay, so it might be you want to copy that down by pressing pause. The next thing, we're going to make this slightly harder. Now, so crank it up a little notch. If we look at this question here, similar question, right angled triangle, but this time it says calculate the length AB, leaving your answer correct to 2 decimal places. Now AB is there, so why is this question a little trickier then? Well, it's a little trickier this time because I'm now looking for a shorter side. Before, I was looking for the long side. But here, I'm looking for a shorter side. Pythagoras' theorem is still true. He said that a squared plus b squared equals c squared. Okay, now, so again, I'm still going to use Pythagoras' theorem in the same way. So I'm going to fill in the numbers that I know. Now a squared, that was one of the shorter sides. So really, I can put 9 in there, 9 squared. B, well, that has to be the other short side, and I don't know what that is. So I'm just going to leave that there as it is at the minute, as b squared. And apparently that will equal c squared. Now that's the longest side here, c, so that's 12 squared. So go to my next line and fill in what I know. Well, 9 squared, again, if I need my calculator, I can do that. 9 times 9, or 9 squared. But hopefully, we're going to get C grade. Hopefully, we know that 9 squared is 81. Plus B squared, I still don't know what that is. And 12 squared is 144. So remember, I'm looking for B now. So what do I need to do next? Well, I need to take 81 away from 140 now. So we've got b squared, sorry, 144. 144, take away 81. So I'm just taking it away from that side. So that means that b squared is 144, take away 81, is 63. So now, what was the next bit? It was square root of 63. So b equals square root of 63, which to the 2 decimal places, my calculator is telling me 7.937 and so on. So to 2 decimal places, that is 7.94 centimetres. And actually, well, I'm glad about that, that number, that answer is smaller than 12. If I'd ended up with a number bigger than 12, it's probably because I haven't done the takeaway bit. Okay, so I need to check that it's smaller than 12. All right? Now, again, I'm going to give you some questions to have a go at yourself. So exam questions. So here we go, let's have a look at them. So we've got question 27 here. So it's a late question. It's a right angle triangle. You will at some stage be asked about this length. So again, it's a clue that it's Pythagoras. That's 14, that's 6. But note, be careful, the very first question is work out the area of triangle ABC. So you need to remember how to do that. But I'll give you the answer for that shortly if you're not sure. B says calculate the length of AB. Give your answer correct at 2 decimal places, so very similar to what we've just done. If you press pause and have a go at that. Okay, so I'll give you the answers to that shortly. Let's have a look at the next one. X, Y, Z is a right angle triangle. Slightly more complicated now. We've got decimal numbers, but exactly the same process. It says here, calculate the length of X, Z. Give your answer correct to 3 significant figures. Now, if you're not sure what that means at the minute, I suggest you do Pythagoras just as we've done before. At least get the answer, so you get at least some of the marks, and we'll see what we do with the significant figures afterwards. Next one. Okay, so PQR is a right angle triangle. That's 16, that's 8. Calculate the length of QR. Give your answer correct to 2 decimal places. And finally, okay, so last one. And often you're told that the diagram is not drawn accurately because some people would try and measure it there, and of course you can't do that if it's not drawn accurately. So your job here, that's 5, that's 9. Your job is to work out the length of BC to 2 decimal places. Okay, so let's have a look at some answers. Right, so here's the first question then that you did. Now, if you're not sure about this, you really need to fix this into your head. The area of a triangle, ABC. To find out the area of a triangle, we do base times the height, and then we divide by 2. So in this situation, it's going to be 42 centimetres square. Calculate the length of OB. So we use Pythagoras theorem, and I hope that you've got the answer of 15.23. for that one. This one, a bit trickier because you've got decimal numbers here, but the same process still applies. Now, this bit here, it said give your answer correct to 3 significant figures. When I square root 12.385, I get 3.51923287 and so on. I want 3 significant figures. So I want the first 3 numbers that appear. So it's the 3.51. However, the last number I'm writing down is going to go up because the number next to it is a 9. So it's going to round up to 3.52 for 3 significant figures. That means the first 3 numbers that I want. And then the next one, that one there is, again, you've got to watch out for this. Hopefully you noticed it. I didn't want to give you a clue, but you were looking for a shorter side here. So that's why we've got the takeaway bit here. So I'm hoping your answer is 13.86 centimetres. Because if it's bigger than 16, then that can't be right. Although if you did do that in an exam, you would get most of them marked, but not all of them. And finally, very similar for this one, you were looking for a shorter side. That's why we've got the takeaway in there. So hopefully, ultimately, your answer is 7.48 centimetres to 2 decimal places. So hopefully now you can use Pythagoras' theorem to find a missing length in a right angled triangle.